Hello everyone, welcome back. This is part 9 of the design patterns tutorial. In this session, we'll do a quick recap of simple factory and we'll discuss how we can enhance the simple factory implementation to factory method pattern. Please refer to the previous parts of the tutorial before proceeding. Now, if you recap the previous example of simple factory, we have extended the employee manager to use the subclasses of contract and permanent employee manager to compute bonus and hourly pay based on the employee type. From this implementation, we can conclude that simple factory abstracts the creation details of the product, and simple factory refers to the newly created object through an interface. Any new type creation is handled with a change of code in the factory class and not at the client code. Now, to summarize, depending on the business requirement, if you are just looking for creation of the object, the simple factory is sufficient enough to address the requirement. Now, if you foresee any requirement changes in future, and those changes are not just confined to the creation of the object, and further, if you need to extend the creation logic to a business level abstraction, which is specific to either permanent or contract employee manager, then we need to extend the simple factory to factory method pattern. You may be wondering how different is simple factory with respect to factory method pattern. Let's take a look at the illustrated diagram. If you compare the simple factory with factory method pattern, you may notice that the factory is replaced with abstract concrete creator, which is responsible in creating the concrete product A and concrete product B that access the products. Now, just because we name the creator as abstract, please note that it doesn't mean this is the abstract factory. If this is confusing at the moment, don't worry. We will address this with a business use case. Let's now take a look at the business use case. If you recollect the previous session, we have already addressed point number 1 as part of the simple factory implementation. Now let's say we need to compute house allowance, which is specific to permanent employee, and we need to compute medical allowance specific to contract employee. Then the current simple factory implementation gets little tricky and complicated. Let's see how we can address this by extending our previous example. Let's bring up the Visual Studio and work on the portal solution that we have been using in our previous sessions. Let's open the employee portal MDF file. Open table definition of employee table. Let's add house allowance. Which is decimal, and medical allowance, which is also a decimal type. Let's click update. Let's update the database. The employee table schema changes are updated successfully. Now let's expand the models and open employee model.edmx. Right clicks on the model and let's update the model from the database. Let's choose refresh, expand tables, choose employee. Let's click on finish. Notice that the house allowance and medical allowance are updated successfully. Let's save the changes. Now let's switch to permanent employee manager and let's address the requirement of computing house allowance. Since the house allowance computation is specific to permanent employee, we are not going to add this at the interface level of iEmployee manager. Instead, we are going to write the implementation at the permanent employee manager class itself. Let's create a new method, public decimal get house allowance, and let's return the allowance as $150 per month. Now let's switch to contract employee manager and let's address the requirement of computing medical allowance specific to contract employee. Let's create a method, public decimal get medical allowance, and let's return the monthly medical allowance for the employee as $100. Let's switch to the employees controller and let's inspect the code at the employees controller which uses the simple factory. You may notice that the simple factory returns the employee manager from the employee manager factory, which computes the bonus and pay for the employee. We have not exposed the house allowance and medical allowance through the employee manager. Hence, we need to compute these values at the point where the simple factory is creating the employee manager. Let's switch to the employee manager factory. Now changing the simple factory, which is in our case employee manager factory, to accommodate the changes is complicated, and we end up violating the principles of creational patterns. So we can solve this issue by providing another layer of abstraction which takes care of computing the common interface operations as well as specific operations related to permanent and contract employee. Let's see how we can achieve that. Let's create a new folder under the existing factory folder, and let's name this folder as factory method. Let's now add all the classes related to factory method implementation under this folder. Let's create a class called base employee factory, and let's declare an abstract method that takes care of creating the respective employee manager. Public abstract employee manager, and let's name this abstract method as create. Let's also change this class to abstract class. Let's resolve this issue by using web.managers. Let's enhance this base employee factory to accept employee object model so that we can compute the bonus, hourly pay and other specific operations. Let's create protected employee, and let's declare this employee as _emp. Let's resolve this employee declaration using web.models, and let's create a constructor, base employee factory constructor, which accepts employee as the input parameter, and let's assign this emp to the declared _emp. Now that we have an abstract factory, let's now create concrete implementation factories for permanent and contract employees. Let's right click on the factory method folder, add new item and choose a class, and let's name this class as permanent employee factory. Let's inherit the abstract factory that we have created earlier, base employee factory, and let's resolve these issues by implementing the constructor as well as the abstract method that we have declared in the abstract factory. Let's enhance the create method, and let's remove this default exception implementation and replace this by computing the house allowance, which is specific to permanent employee manager. Let's create permanent employee manager. Let's name it as manager equal to new permanent employee manager. Now let's compute the employee dot house allowance equal to manager dot get house allowance. Let's return the manager object. Let's do the similar steps and implement contract employee factory. Right click on the factory method folder, add new item, choose the class, and let's name this class as contract employee factory. Let's inherit the base employee factory and let's implement the constructor as well as the abstract method. Let's enhance this create method and let's remove this default exception and replace this by computing the medical allowance which is specific to contract employee. Let's say contract employee manager equal to new contract employee manager. Let's compute the employee dot medical allowance equal to manager dot get medical allowance. Let's return the manager object. Let's now switch back to the base employee factory. You may have noticed that we have implemented the operation specific to contract and permanent employees in their specific factory methods. The next step is to compute the bonus and hourly pay, which are common for both contract and permanent employees. We can achieve this by leveraging on base employee factory. Let's create a new method in the base employee factory and call this method as apply salary. Let's create public employee apply salary method and let's compute the bonus and base pay using employee manager is equal to this dot create. The abstract create method will take care of returning the corresponding employee manager interface. Let's compute underscore emp dot bonus equal to manager dot get bonus. Similarly, underscore employee dot hourly pay equal to manager dot get pay. Let's return back the employee. Now that we have segregated the operations on employee into respective factory classes, let's now integrate the factory method implementation. Let's create a new employee factory manager class under this factory method and let's return the respective factory objects based on the employee type. Right click on the factory method, add new item. Let's choose a class and name this class as employee manager factory and let's create a new method under the employee manager factory which returns base employee factory. Let's call this method as create factory which accepts employee object emp. Let's resolve this issue by using web.models and let's create base employee factory as the return value. Let's assign null value to this. If emp dot employee type id equal to 1, which means it's a permanent employee manager or a permanent employee, let's assign the return value equal to new permanent employee factory and let's pass the employee object. Let's also say else if employee dot employee type id equal to 2, which means it's contract employee. Let's assign the return value equal to new contract employee factory and let's pass the employee object. Now let's just assign and return this return value. Return value. Let's now integrate the changes in the employees controller. Let's open the employees controller and let's replace this simple factory with factory method implementation. Let's use web.factory.factory method and let's move to the create and instead of Using the getEmployeeManager, we are going to create the factory and pass the employee object, which returns us base employee factory, which is base employee factory. Instead of using iEmployeeManager, let's remove this code and say employee factory dot apply salary, which takes care of applying the bonus as well as hourly pay as well as rest of the operations related to the permanent and contract employee managers. Now let's compile this application. Before running this application, let's switch to the list view of the employee and add the house allowance and medical allowance columns to the list view. Let's open the index.html and let's scroll down and let's add mod item dot house allowance, and let's also add item dot medical allowance. Let's also add the headers to these columns over here and say, let's just copy this and say model dot house allowance, and let's also say model dot medical allowance. Let's now run this application. Let's choose employees. Let's create a new employee. Let's name this employee as Michael, job description as manager, number as A2345, department as IT. Let's click on create. Look at that. The new employee Michael is created as permanent employee and his house allowance is computed as well. Let's do it one more time. This time let's do with the debugging on. Let's switch to the code. Let's go to the employees controller and put a breakpoint before creating this employee. Let's go back to the IE and let's create another employee called Jason, job description as contract employee, number as C3456, department as development, and let's choose employee type ID as contract. Let's click on create. Let's press F11 during the factory creation. Notice that employee type ID is true. We are creating a contract employee factory. Let's step into the code. Let's look at that. The employee object is assigned and the contract employee factory is created. Now let's return the value and click on F11, apply salary. If you inspect the code, the apply salary method is creating the iEmployeeManager, which is further computing the bonus and hourly pay and returning the employee object. Let's run this application. Look at that. New employee Jason has been created as a contract employee with medical allowance as 100. With this, we have successfully addressed the business requirement by enhancing the simple factory to factory method pattern. Now let's revisit the Gang of 4 definition about factory method pattern. As per Gang of 4 definition, we define an interface, which in our case is an abstract class, for creating an object, but we let the subclasses decide which class to instantiate, which is in our case are permanent and contract employee factories. And hence we can say that the current factory method lets a class defer its instantiation it uses to subclasses. In the next session, we will discuss and learn the abstract factory pattern. Please feel free to post your comments and feedback in the comment section. Thank you for listening and have a great day.